Hi everyone, here's our math problem for today. Inside a rectangular box with a length of 30 inches, a height of 12 inches, an ant is located at the middle of one side, 1 inch from the bottom of the box. This distance here is 6 inches and another 6 inches because the ant is at the middle of a box with a width of 12 inches. Now on the opposite side here, there's a drop of honey located at the middle of the opposite side, 1 inch from the top. Now the question is, what is the shortest distance that the ant would need to crawl in order to get the honey? You can pause the video and see if you can solve this math problem. Now let's solve this problem together. The common tendency is to measure the distance this way. From this point that is 1 inch above the bottom, we go up this distance, which is 11 units, and then we travel this distance going here, which is 30 inches, and then we go down 1 inch in order to arrive at the honey. And so for the computation, we have this 11 inches plus 30 inches plus 1 inch equals 42 inches. But unfortunately, this is not the correct answer. So how are we going to identify the shortest distance that the ant must have to travel in order to arrive at the honey? In order to answer this question, we need to think outside the box. One way of answering this problem is to open up the box this way. This is the ceiling of the box. This is the floor of the box. So that means this is the side and this is another side. Now the ant would be located here and the honey is located here. For the dimension, the ant is at the middle, and since the length of this is 12 inches, that means this is 6 inches and 6 inches here. The length of the box is 30 inches, and again, this honey is at the middle, so the distance here is 6 inches, and we are looking at this right triangle. Now, for the height of the triangle, the height must be 10 inches because the ant is located 1 inch above the bottom, and the honey is located 1 inch below the top. Now, using the Pythagorean formula, if we let the distance traveled by the ant as d, then we can compute d as the square root of 10 squared plus the square root of 42 squared, where 42 is the sum of 6 plus 30 plus 6. And this gives us a value of d equals 43.17, which is even higher than the 42 inches that we computed earlier. So this must not be the correct answer. So how are we going to open the box in such a way that we can determine the shortest possible distance that the ant has to crawl in order to get into the honey? Now let's have another try. Let's say we open the box this way, and again, this is the ceiling. This is the floor, here's the location of the ant and the honey, and for the dimension, here are the dimensions. We are now looking at this right triangle again, so we want to find what is the height of the triangle. We know that the distance of the honey to the top is 1 inch, but this is now sideways because of the way we open the box. So that means the base now of this right triangle must be 1 plus 30 plus 6, which is 37 inches. And for the height, this is 6 inches here. And since this height is 12 inches and the ant is located 1 inch above the bottom line here, that means the distance here must be 11 inches. And that gives us the height of the right triangle as 17 inches. And solving now for d, d is the hypotenuse. We have d equals the square root of 17 squared plus 37 squared. And this gives us a value of d equals 40.72 inches. Notice now that this is lower than the 42 initial value that we arrive at. But this is not yet the least possible distance that the ant can crawl. So let's have another scenario. Let's say we open the box this way instead. Let's position the ant and the honey with respect to the ceiling and the floor of the box. And let's put now the dimension. So here, the ant is located 1 inch from this corner. And again, this is 30 inches. This again 1 inch. And the base now is 1 plus 30 plus 1, which is 32 inches. For the height of the right triangle, again, this is 6 inches here plus 12 inches. And then, again, this is 12 inches here, but that is divided into two parts. So this must be 6 inches. And so the height of the right triangle is 6 plus 12 plus 6, which is 24 inches. And solving now for d using Pythagorean formula, d is equal to the square root of 24 squared plus 32 squared. And this gives us a value of d to be 40 inches. And this is now the least possible distance that the ant has to crawl in order to get into the honey. And going back now to the three-dimensional rendering of the box, this is now the path that the ant has to crawl in order to get into the honey. And the distance is 40 inches. So thank you very much, and we hope to see you again in our next video. Bye for now.